Hello friends, welcome back to my channel, Vartita Learning Platform. And in this series of socket programming, today I am going to create a new video for you where you can see how to create a multi-client server. Multi-client means, let me just make some comments here. I will just share this code as well with you. Multi-client means a server which can handle more than one client connections at a time simultaneously. Okay, so in the previous video that I uploaded and that you might have seen, that was only for handling a single client, but this will be handling a number of clients at the same time, right? So, but again, here I have made it only to handle for 5 clients at a time. You can make it to handle 20 or 30 or whatever you want to do, but for the demonstration purpose, I have made it only 5. And with the description I will follow for this program that I have written, I will tell you the important things that you need to take care of when you are writing a server for your program, for your project, right? So let's start with the beginning, like how to start writing the code. I have already written the code here because the code is so lengthy that if I start writing and explaining at the same time, then it might take around 1.5 or 2 hours, and it will be a very long session. And so I decided that I will share the code with you guys for both the multi-client server as well as the client for the demonstration, the client for testing, right? This will be the server code. Also, I have written the code for the client. This is the code for the client. So with the help of the client, we will see that how we are able to connect to the server, how more than one clients are able to connect to the server, and how they will be having the different connections here, and how our server will be handling all of those clients one by one. Okay, so first of all, when you are writing a program, I have started it from the main function. So here you can see, like, I have taken one variable and n rate for for checking the return values of the APIs. And before we call any of the functions related to the socket APIs, socket system calls, first of all, I have called this function WSA startup. I have already explained this function in many of my videos, but again, let me tell you again this thing, like this is all about to start a Windows socket environment. You just need to use this latest version of the WSA, and then once you call this WSA startup function, if this WSA startup is successful, then in that case you will be able to call all the other functions. But if you are not able to call this function successfully, or you can say like it returns minus it returns -1, just like here I have just taken it here. If it returns -1 less than 0, then apart from displaying the message, you can do one more thing. You can just call like return exit failure. Okay, so exit failure is nothing but a standard macro. Okay, I don't want to explain this one. This is a standard macro which whose value is -1, right? Sorry, it's 1, right? And when you return from a main function, then where does your main function returns? It returns to the operating system. So we need to tell the operating system that our application was closed because of some error. But when you use the exit success, then in that case, it means that your server was, your program was successfully returned. No issue was there. Without any failure, all of the things were successful, and then your program returned. So this exit failure and exit success you can check by yourself. So let's move to the first system call, which is the socket call. And I have already explained in many of the videos, but again, the first argument is AF_INET, which means what is the protocol family. This is basically the protocol family. If you want to read about the protocol family, you can search it on the Google, and you can get a vast description around this, like what is AF_INET, what is the other address families that you can use. Apart from that, the second argument is what kind of socket you want to use. So we want to use the stream socket. I hope you know about the stream socket. Stream socket means when you use the stream socket, then every time the connection should be open. I mean, a connection should be established all the time till your communication is going on. And in case of UDP, like SOC a dgram, that is the datagram socket. For that we use the dgram. So in case of UDP, you don't want any open connection, active connection between your client and your server when you are using the UDP. But in case of the stream socket, or you can say a connection oriented socket, which is represented by this macro, which is sock stream, in that case you need to be connected with the server all the time till your communication is going on with the client, right? And the last argument is what protocol you want to use. We want to use the TCP protocol, transmission control protocol, for our communication between the client and server, right? So this is the number of arguments that we use, and if this function fails, which means if the return value is smaller than 0, then we will simply make a statement that socket cannot be initialized and we failed. Exit failure, that will come. And after that, what we need to do, this is the socket which is the listener socket. We call it the listener socket. Why we call it a listener socket? Because we will use this socket for listening to the new connection, right? Don't worry, I will explain one by one everything. This is the listener socket which you are creating as at the server. Why it is a listener socket? Because using this socket identifier, you can say this file descriptor, because any socket that you have got it from the socket system call, that is always a file descriptor, or you can say the socket descriptor, right? So whenever you get a file descriptor through the socket call, that is used at the server end for listening to the active connections. That is the purpose of this socket, the listener socket. So now, before we start listening to the to a particular port, we need to define a port. So I have defined this port on the top. If you see here, this is the port. 4 times 9, 1. So 99,991 is the port number. I have written it here, and I have just used this H2NS. I have already told why we use it, because of the network byte order, right? I have explained about the network byte order. If you want to see the details, you can visit my playlist of socket programming, and you will find the description even in the previous video that I have uploaded. So H2NS, what it does, because every information when you are connecting over the socket, all the information goes in network byte order. Network byte order is the big endian format. Big endian means most significant byte first, right? So that is why you have to convert. Let me just write it here, most significant byte first, MSB first, right? Because in this order only the information is sent over the network. So that is why we have to set the port using this H2NS only, because H2NS converts any number from least significant byte order to the most significant byte order. By default, our port number that we store the information, that is in the least significant byte order. All these things like least significant byte order and the most significant byte order, I have explained already in the earlier videos of my playlist for the socket programming. So I would suggest that go through all the videos that I have made on socket programming on this playlist on my channel. And this video specifically I'm making because there was few requests, like there should be one complete thorough video where everyone can find a single place where they can find all the code related to this server, multi-client server, and as well as the client. So that is why I'm making this video. Otherwise, all the things I have already explained, right? So I hope this video will be helpful to you. So this thing, I think you got it. H2NS, why we use it? Because we need to convert any information to the network byte order, which is the most significant byte first order, so that this information can be used for the networking, for network connections, because all the networking things takes place over the MSB first, most significant byte order first. And then we need to provide the address, the local address, where IP address basically, where we want to listen for the coming connections, for the coming clients, for the incoming clients. So this is the inadder any is basically a macro, and mind it, only for the server. When you are writing the code for the server, then only use this macro, only for server, not for the client. It can be only useful when you are going to call the bind function. It is not useful when you are going to call the connect function, that is from the client. when you are using the client code, when you are writing the client code, please don't use this, right? It is only useful for the bind system call. In the bind system call only this can be replaced with the it calculates the local IP address and assigns it to the s underscore header, right? So this code is assigning the IP address of the local machine, or you can say the local server, on which will be explored to which will be exposed to the outside world, to which address any of the client need to connect on this port number, right? So this is the important point that you need to take care of. And the other one is the mem set, which I have already told you in the previous videos as well. Like this sin 0, this need to be clear with the 0, and the size is 8. This sin 0 side is basically 8, right? Even if you don't want to provide 8, the correct method is size of srv.sin0, right? But we know the size, so that is why I have provided it 8. But mind it, this is not a good practice. Always use macros, or always use the right way to make your code more readable, right? So just for the demonstration, I have just used these constants, but mind it, this is not a good practice at all to use the constants in your program. Either use them by declaring them as the macro, or you can just simply use the methods that need to be called here to make it more relevant or more readable, right? So here if I use size of srv.sin0, then everyone reading this program will be aware that yes, this is the size of this particular member, right? And after that, you need to bind it. In the bind system call, what you need to do, you first need to provide the listener socket, then you need to provide the srv, and this srv I have already declared on the top. If you will see, I have declared it here, srv, but mind it, I have declared it as sock header in, right? But here what I have done here, I have typecasted it in the sock header asterisk, because both can be typecasted, right? Both are compatible. This can be converted to that, right? Or you can say the sock header in can be converted to sock header asterisk. Typecasting is possible for them. So that is why I have typecasted. And then the last argument is what is the size of the structure that you want to use. So this is the structure that I'm using. So this is asking for the size of that structure. So that we have provided. And so now we have bound at this port using this bind call. If this fails, then I'm simply returning it from here. Exit failure. And I have already told you about these things. Exit failure. Okay, if this passes, then I'm going to start listening on the listener socket. So here I bound successfully on the port, and here I'm going to listen. So if I'm going to listen here, then I have set the limit of 5 clients, which means that at a time simultaneously I'm going to listen for 5 clients at a time, right? So mind it, if you are writing your own application for your project, this is not a right practice. You must need to provide number of clients. So provide the number of clients you can listen based on the architecture of your program, based on what your architect had suggested for your design, right? So here I'm not going to discuss about the designs that are done around the socket programming. Here I'm just going to tell you what you have to do to create a multi-client server, right? So here I have just mentioned it 5, so that only 5 I can listen, only 5 sockets, only 5 new connections from the client I can listen, and here I need to provide the N socket, which is the listener socket. So I'm listening on the listener socket. Okay, if it fails, then simply exit failure. And after that, you need to, now there will be a difference. In the previous video, when we were discussing about the single client server connection, there was only one server, there was one client that we discussed in the previous video. That was a different story, but here we are going to listen to a number of clients. So now from here onwards, please listen carefully. So here I have used a structured time interval, time val. Why I have used it? Here I have provided this number of seconds as 1, and here I provided the number of microseconds. This use seconds means number of microseconds. So here I have provided the microseconds as 0. Just keep it noted. I will let you know why I have used it and where I have used it. After that, the most important thing is the max FD. This max FD I have already declared on top. If you go to the top, you will see that I have declared it here as 0 as a global variable, right? I have taken these variables as global variables just for the demonstration purpose. But again, if you are writing a good code, if you are writing a code for your project, and if you are writing in a C++ code, please choose your variables wisely. Choose your variables private, protected, whatever, based on a good programming practice that you should follow. Just like these things, they should not be never exposed. These variables, all these things should be encapsulated inside a class. But here, just for the demonstration purpose, I have written it in the simple C language, right? I have not used any C++ kind of code. It's a C style code that I have written here just to make the concepts clear around the socket programming, right? So let's come back. So let's understand this maxfd. What this maxfd means. Basically, when we are going to, just listen carefully, okay, when we are going to listen to the number of clients, so there are two things. One is listener socket, which is listening, right? There could be, apart from that, there could be new clients, right? There could be new clients which could send you message, which could send you message after connection. Okay, after making an active connection with your server, they might be, they might want to send you some messages after connection, right? So listener socket will listen to the new clients, and this new client or whatever new client is coming, and this listener socket. Listen carefully. All these things we set in the FR. There is an FD set FR, right? FD set is a data structure that I have declared on the top. This is FD set FR. Why I will use this FR? This FR is the variable name that I have given. You can give any name to this, fread, anything. So what I have done, I have just given this name, and this is the FD set. And this FD set, if you will see this, go to the definition, then this FD set is basically array of bytes, right? It is an array of bytes. If you go deep into this is an array of bytes. So anything, just come back, anything like listener socket or any new client socket, all these sockets are basically some file descriptors. They are simply the integers, right? So all the integers values that you are getting through the new clients, either through this socket call, all these are the integer values, and all these integer values are set into this bit set, right? This is a set of bits, and here you set it, right, in FR, right? That we will do in the coming while loop, right? So all you set in this FR. Why you do this? Because you have to read on this socket, on this set. This is a set which we have created to let the program know through the select system call, which I will explain later, right? So through this select system call, all this FD set where we can read any information, you can understand that whether it's listener or whether the new clients that you have created, that you have connected, all those are what kind of activity you are going to perform on them. You are going to read on them. Reading listener for new connections from the new clients, and reading the clients that you have already connected for the new messages that they could send. So overall you are performing a reading activity. So for that reading activity, we will set all these sockets, listener and new clients, in this FR, which is an FD set. I hope you got the point, and this is very, very important point. And why I have used this maxfd? Maxfd has been used because I already explained you this is a set of bits. So that every bit is covered, every bit is set by this select call. This select call is specific. This select call is very important. This select call checks every bit of this bit set, which is an FD set, right, that I have created, right? So this FD set is read by this select system call for every bit, and to ensure that every bit is read by the select system call, we provide this nmax fd as 1 greater than the maximum fd available. So as of now, the maximum file descriptor, fd means file descriptor, maximum file descriptor value that is available is through this socket system call. You can understand, right? This is the only system call through which I have got a new fd, a new file descriptor. So obviously this is the maximum socket value, right? So this maximum file descriptor value will be set into this fr, but to ensure that everything is covered, I give it +1, right? So if I give it +1, then we are sure that every time it will be able to cover every single bit inside this fd set. That is the whole purpose. And even if you don't provide this +1, then also your solid system call will mostly work fine, but at some point of time this may fail. You cannot guarantee that every fd has been read by this select system call that we are going to discuss just right now, right? So that is why please keep in mind that to ensure that every bit inside this fd set, we are going to put all the listeners and all the new clients that are connected, they should be properly read by this select system call. That is why we have provided this nsocket +1. Okay, now let's move ahead and keep this in mind right now. Keep this noted as of now. I will come back again to this max fd. Okay, now what we have done, I was talking about the fr, this fd set. So what I have done inside this while loop, I'm running a while loop now, so that I can keep listening for the new connections. I can keep listening for the new messages that a client could have sent. So all these things, sorry. So all these, so to check all these things, I have called this select system call here, and I have provided this max fd here. So this takes max fd, and apart from that, it takes the fr, right? So I have done this like for, first of all, I have make all the fd set bits 0. Through the fd 0, I have reset all the bits, and after that I have called fd set. I have made 0 first, and then I have called fd set to make the socket available to this fr, right? So this is the listener socket. I am assigning this to the fd set fr, right, which is the reader socket list. All the things are reader, whether you are listening for a new connection or you are waiting for some message to come on an existing client connection. All these activities are basically the reading activities, and that is why I have used here, I have provided this thing nsocket into this. I have set this, set the bit of the value which is in the listener socket to fr, which is the read socket. Okay, and after that, what I have done here, you can see a loop. Why this loop has been used? I have declared this n client socket here. This is the n client socket. This is the array of client sockets. Whenever a new socket, whenever a new client will come, I'm just assigning those, storing those new clients in this array, right? Again, this is not the standard practice, and this is not you should write your code. Just for the demonstration purpose, I have hard coded the number of clients that I'm handling, right? I hope you are getting the point. So what I have done, I have already told you that any client socket, in the beginning, this client socket will be empty. Everything will be 0, right? You can see that wherever I have declared it, you can see that I have initialized it with 0, which means that initially in the client socket, there will be nothing. There will be no active connection, right? So what is happening here? When you come here, I'm just ensuring that all the socket descriptors inside this client socket array, they are also set into this reading socket list, readers list, fr, right? So n client socket n index, this is the value, and here it is set as a bit, right, for any client socket which is available. Initially, for the first call, when you will enter first time in this loop, please mind that this will never execute. This if condition will never be true, because initially you don't have any client, right? So this will never be true. But when you have at least one client, then every time you need to make first all the reading descriptors 0 in the read set, then you need to put all these socket descriptors for the new connections, for the listener socket, and for the client socket in this FT set, right? and you need to make this FD set again for everything that is available to you as a socket descriptor. Why we need to do this? Please mind it, right? Please remember it. Why we need to do this again and again, right? You can see that you might think like I can do it only for the first time. I can do it outside this while loop. No, you cannot do this outside while loop, because every time you call this select call is very important. Every time you call this, make the call to select system call, what happens that after it returns, you can see that I have provided FR here, address of FR, which is the reader descriptors, right? Where you are reading, right? The socket connections where you are reading, where you are waiting for something to come, right? Either a new connection or some new message from the existing client. The second and third argument, the third and fourth argument, I have made them 0. Basically, this third argument says you can provide the writer descriptor. Here you can provide those descriptors which are throwing the exception, but I don't have to care about those, like where I'm going to write and where I'm going getting any exception. So that is why I have provided them as null. And then I have provided the time interval. You might have seen that I have used this struct time val. So I have provided the time interval here, right, in the select call, and this is the 1 second time interval. So what does this mean? That the select system call will check all these number of for all this maximum number of value here, max FD, for all this maximum number of value inside this FR, which is the file descriptors of readers, where you want to see if anything is there to read on the socket on the port, right? And this is the time interval, which is the 1 second, which means before the select system call returns, it will simply wait for 1 second, right, before it returns. After 1 second, when it will return, if there is any new connection, or if you have a new client already, right, if you have a new client already and that client has sent some message, then this FR will be set, and here nret will return 1, which means one socket is one file descriptor is there which is ready for read, right? So this is the purpose. And the other thing is that every bit in this FR, please mind it, every bit in this FR that you have set here is reset after this select call. Let me just make a statement here so that with the code this will be available to you. After above call, every bit is reset by select call in FR, right, in file reader's descriptor. Okay, so this is the select call which is used to have this checked whether any of these sockets that we have already here in this FR, they are ready to read anything or not, right, on the port. Okay, so there could be 3 results, right? First result is nret is smaller than 0, which means that select system call didn't work properly. In that case, what we will do, we'll simply return. The second case could be that nret returns 0. When it returns 0? It returns 0 when there is nothing on the port to read. There is nothing on the port to read, which means that simply we have polled the port and there was nothing there, and so we will simply make a message here that no client at port waiting for an active connection, right, or any new message, right? This is the half message, active connection, new message. This is the complete message. So there is nothing new to read, or there is nothing new to connect with a new client, right? Else, the third case is the else case, where nret is greater than 0, right? There are 2 cases. Now the third case is obviously nret is greater than 0. So if nret is greater than 0, which means there is something waiting on this on the port, in that case what happens, that if FDH set, through this FDH set, what we do, through this FDH set we check whether our listener socket is ready or not, right? What happens, that every bit is checked by this select function, but if there could be 2 possibilities. One possibility is that your listener socket is getting a new connection request for a new client. In that case, you will see that FD socket is true for your listener socket. This will become true. FD set is used for that purpose only. And if that is the case, then you will go to this handle new connection, which means that you are going to accept a new connection. Now let us see what is happening inside it. So here you can see like handle new connection, we are calling this new function accept, right? What I'm doing, please mind it, when you are listening on a socket on the server, then that listener socket is always listening on a particular port, always for that purpose only that is used. But when a new connection comes and you call this accept, then in that accept call, you provide the first argument as the listener socket. Please listen carefully. And the second argument and the third I have provided null, right? The second argument and third argument, if you want to use, you can use. What happens when you use them? Basically, second argument contains the information, something like this, socket address in. For what? For the client connection, from where this request for connection has come. So if you want to store the information related to the client that has requested to connect to you, that you can use here. That you can, if you want to use that, you can use it here, and you can simply accept the connection. And after accepting the connection, the new client will be returned here. That new client will be a new file descriptor. Please mind it. And new client will be a new file descriptor, and now the client communication will take place using this connection only, this socket only, this file descriptor or socket. Okay, so this will be the new client socket descriptor, or you can say the file descriptor, using which the ongoing connection, ongoing communication, the communication going forward for this client will take place using this socket, which means this socket which was used earlier, listener socket, this listener socket is only providing you the help to get a new client socket, so that you can communicate using that new client socket. So that new client socket has been provided here after the accept system call. So with that accept system call, you now have a new client socket. Now what you have to do, if this new client socket is smaller than 0, then obviously you can say like not able to get a new client socket, and you can return from this function. Okay, but if you have got a new client socket using the accept function, then what I have done, I have simply done like in this client socket array, you know that this is the client socket array. Inside this client socket array, I have checked for a position which is available, right? And the available position is something where the client index is 0. The value at a particular index in that array is 0. So wherever I found that there is a 0 value, which means there is no client socket assigned. So in that case, what I will do, if there is no client socket assigned, I will simply assign the new socket, which is the new client socket, to this array at a particular index, right? And now I have this new client using which I can listen for the new messages from the client which is now connected with me. Using the accept, I have connected now, right? Using the accept call, I have connected now. I have accepted the new connection, and I have stored this in the new client socket, right? And one more thing, I already told you that this select system call always checks for the max FD. So it may be, please listen carefully, it may be that the new client socket that you have found, right, it may have a value greater than the listener socket, right? So if this value is greater than the max FD, which was earlier the listener socket, then in that case you need to reset this max FD value. right? Otherwise, no. Why? I have already explained that why you need to have this value greater than 1 from the existing client socket, right? So max FD, you need to provide this and new client plus 1, right? So this will be the max FD. If this is greater than max FD, then max FD should be replaced. And why? Because the number of bits that you need to check through the select system call, they should be, they should make some sense. They should be in such a way provided so that select system call knows that how many bits I need to check before I can ensure that I have checked all the socket descriptors, or you can say all the file descriptors. Okay, so this is all about this new connection handling. And after that, what I have done, if index is equal to 5, which means if more than 5 connections have came and I have already connected to 5 clients, then I will send the message to the new client that server is busy, I cannot accept your connection. Okay, so this can be done, this can be sent to the client, right? So here please mind it that I have used it only for the demonstration purpose. This is not the way you will code in your real project. Please mind it, don't do this mistake, otherwise your manager will be very unhappy with you, your reviewer, your architect will not be happy with you. Okay, so we have understood this function now, why we used it, handle new connections, and now we are going to understand this function, handle data from client, right? If my client, if my listener socket is set, then I have used this handle new connection, because if my listener socket is set, then which it means that there is someone waiting for a new connection, there is some new client waiting for a new connection to make with this server, right? But if this is not the case, then obviously there is something available on one of the existing client sockets. Some client has sent some message, right? So for that I have written this function, and this function is very simple. Let us go. So here what I have done, I simply iterated through 5 client array of 5 clients. So here I checked which of the sockets. First of all, I have checked which socket, which client socket index is greater than 0, because if clients, whatever client socket index is greater than 0, only that can have some message from a particular client for that client, right? So first thing, just check which client index is greater than 0 in the client array, and then check if that client index is greater than 0, then I need to check if again this FD is set. Now I'm checking whether the new client socket, right, client socket, not new client, the client socket that I have stored, whether that particular socket at a particular index, right, is available there to read some message. If that is available to read some message, in that case what will happen, again this is same FR, what will happen, I will simply receive the message which is coming from the client. If I have not received the message, smaller than 0 something comes, this comes, let me just put it here, smaller than 0, this happens, I have already written it, sorry, this happens when client closes connection abruptly. If client closes the connection abruptly, then in that case it returns -1, and in that case you need to close the socket at this particular index, and also make this slot, which is this particular index in the array, in the client array, make it as 0 so that it is available for any new connection. Basically, if some error comes through some client, then simply there is no need to retain that particular socket descriptor for that particular client, right? Okay, now in the else part, if this is not the case, then in else part I am just printing the message that has been received from a particular client. Okay, so this is the server code, and this is the entire server code using which we are listening to from the clients, and we are listening from the clients for new connections, and we are listening from the clients for any new message that they might send. Okay, so let's go to the client's code. This client code is very simple. Again, you need to use this WSA startup. You are opening this socket. I will share this code. There is nothing special in this code. And after that, again, here you need to take care, like in case of server, I have used in header any, but here You cannot use that. I have hard coded this IP address because I know what is the IP address of my machine, but this is not the right way to provide the IP address. You can use get host name, get host by name. Those APIs you can use to get your own IP address correctly and then assign that IP address using this inet underscore header system call to this s underscore header, right? So basically this inet header, why I have used, I can provide this simply strcpy as well, but why I have used just inet header? Because again, the same thing, this inet header is converting this IP address into network byte order, which is the big endian format, right? So that is the thing we need to do. And again, this port number, I know which port to connect. So this is 4 times 9, 1. So 99,091. And again, this MAME set is again the same. Here you need to call the connect because you are not server, you are client. So you will connect. So you are going to connect through this client socket. And here you have all the arguments that I have already discussed in previous videos. So here you need to provide this sock header asterisk to this SRV, which is here. Here I have declared it. So this is the way you can use it. After connection, if the connection is successful, what I will do, if the connection is successful and if the connection is accepted, then it will return greater than 0 and you will come here. So after every 2 seconds, I am sending a message. I'm asking the client to send the message. I will type the message and then this message will go to the client. Server, and server will print this message. Now this is the time for demonstration of the code. Okay, so let me just first run my server. Okay, if I'm just running my server, right, if I'm just running my server, then what will happen, it will simply keep printing that there is nothing, no client at port waiting for any active connection, right? But now if I run some client, right, now I am running some client. Now I already told you, when the client gets connected, it will ask you, it will come to this while loop, it will ask you what message you want to send. So here I'm going to provide the message which is hi Vikash, which is my name, and I'm going to press enter. Once I press the enter, this will reach here, and here what will happen, it will simply print those messages at the server side. You can see receive data from 296. This is the socket from the client for a particular client, and this is the message which was sent by this client, hi Vikas, right? So you can see. So I already told you, if you want to print the address and the client, in that case you can use here, you can store here when you are accepting the connection, you can use the struct sock header srv or client address value here, and that will be the same. You need to just create one more structure like this, and you can just give the name, some other name like sock header in client, and you can store when you are accepting the connection. At that time only you can store the name, the IP address and the client socket for that particular client in some array or in some structure, somewhere in some data structure you can store that. But here, just for the demonstration, I have simply used the client socket that was available at the server end after getting connected to the client. Okay, so this is the way you can simply get the connection and print it, whatever is coming. So now let me do one more thing. I can do one more thing, like let me check what is the place for this particular code. Let me just check where this code, where is this file where I have created this. So open containing folder and go to the debug, and here, okay, it's not the right place. Okay, let me go to up. Okay, here is the output. So this is the socket client, right? So one socket client I have run directly from here, and now one socket client I'm going to run from here, right? So that I can demonstrate you two clients. Okay, so I came here and I just do socket client, right? Now this socket client here, again I need to accept this connection, and again this new socket need to send a message, hi new Vikas, right? Let us see what happens here. So this will come here, and you will see that here on the server side, this is the server side code. You can see that this time it has received the message from a new client, this file descriptor 220, because two clients I have used and both the clients have different client socket descriptors. So this is the way you can distinguish that which client is sending to you, right? And using this socket descriptor, if you want to change the code, if you want to do something more, what you can do, you can simply send the message using this client. Suppose here I have just read the message here in the handle data from client. What you can do, before the break, you can add one more code here, and in this code you can send a message. You can call the send API and write there like, yes, this is the client connection. You know this socket descriptor from the client. So using this client socket descriptor, you can call the send socket API, right? And using that socket API, you can send the message that yes, I have received your message. And you can do one more change here. After send, you can here write receive, right? What that receive will do, that receive will receive the message from the server that I just told you that you can send, that yes, I have received your message. That acknowledgement you can check here. So that I leave it up to you. If you face any problem in that, just let me know in the comment section. I will create one more video, right? But I want to make this socket programming really simple for you guys, so that you become a master at least in this particular basic concept of socket programming. Okay, so I hope you enjoyed this video, right? And I already written this code, and I will share this code with you guys in the comment section. Please see the comment section. There will be two comments. First comment will be for the client server code, and the other comment will be for the client code. So both the codes I will provide to you, and then you can use that code and you can run it on your own, on your system, and enjoy, right? So happy learning. Please like the video, subscribe my channel. There will be more on this channel, and you can explore my channel. There are a number of playlists related to data structure, related to design patterns. You will find you will keep finding new things every day here, because our team and myself, we are going to add as much as technical stuff, the programming language related stuff, and any new thing which is coming in the market here only, right? So our videos will be in English and Hindi both, right? So few playlists are there in Hindi and few playlists specifically for this socket programming as well. I'm going to prepare a playlist in Hindi because that is in demand, right? So Hindi and English, right? Both the way our playlist, our channel will contain the video list. Okay, so I hope you enjoyed it, and I hope you will like this video today, and I hope you will check yourself like how your program is running, and I hope you will comment soon that what kind of issues you are facing, even if you face any issue. Okay, so that's it for today guys, and I hope you enjoyed it. Have a nice day, and bye bye.